What we're going to do is we're going to use trig ratios to simplify each of our trig expressions. So the 6 formulas that we're going to look at is tangent is equal to sine over cosine, cotangents equal to cosine over sine, secant is equal to 1 over cosine, and cosecant is equal to 1 over sine. So as the example goes, we have cotangent times sine. Cotangent, we know from up here, is cosine over sine. Sine, we're just going to keep it as sine over 1, and the sines cancel, so what we get is cosine. Now, when we're doing each of these examples, what we're going to do is we're going to take each of our 6 trig ratios, and we're just going to narrow them down to sines and cosines, meaning that we're taking our tangent, cotangent, secant, and cosecant, and turning them into sines and cosines. Sine and cosine we're going to keep the same, and then what we're going to do is we're going to simplify as much as possible. So when we're looking at example 1, letter A, what we have is cosine times tangent. So cosine I'm keeping the same, and then tangent is sine over cosine. Cosines cancel, and so my answer is sine of theta. Theta is just a variable, just like x. Secant, we know, is 1 over cosine. And cosine, we're just going to keep it as cosine over 1. And we see that both of them cancel, and our answer is 1. Tangent, we know, is sine over cosine. And secant is 1 over cosine. What we're going to do is use keep, change, flip. So we're keeping the sine and cosine the same. We're changing the division to multiplication, and we're flipping our second term. So that would be cosine over 1. Cosines cancel, and so our answer is just sine. For the next one, we keep the sign the same. So we have sine of x over 1. Cosecant is 1 over sine. And so the signs cancel, and what we get is 1. Tangent is sine over cosine. And cotangent is cosine over sine. We see the sines cancel, the cosines cancel, and what we get is 1. And what we have is cosecant. Cosecant is 1 over sine. Then what we have is cotangent, which is cosine over sine. We're going to use keep, change, flip again. We're going to keep the first one the same, 1 over sine. And we're going to multiply it by sine over cosine. The sines cancel, and what we get is 1 over cosine. And we know 1 over cosine is secant. So we're going to make it as simple as possible. Now what we're going to do is we're going to do a little bit of review of factoring to get us ready for more difficult factoring in terms of Algebra 2. What we're going to do is we're going to take our trinomial. We're going to use the x method. 2 numbers that multiply together give us 10, add up to -7. That would be -2 and -5. So our answer is x minus 2 and x minus 5. With the next one, whenever we have a binomial and both we can find the square root of, we're going to take the square root of each one, and then that becomes x minus 2 and x plus 2. Now for letter C, we have a trinomial, but we have a leading coefficient. Whenever we have that, we're going to multiply the leading coefficient and our constant term, and that's going to give us 12 and 7. So 2 numbers that multiply together give us 12. Add up to 7 would be 4 and 3. But because of the leading coefficient, we're going to divide each of these by 2. And that gives us x plus 2 and 2x plus 3. Now for letter D, we're going to do the same thing. We're going to use the x method. 2 numbers that multiply together give us -20. Add up to -1, and that would be -5 and 4. So what we have is x minus 5, and we have x plus 4. Letter E, what we have is binomials, and we could take the square root of each of those binomials. So that would be x minus 7 and x plus 7. And for our last one, we have a leading coefficient. So we're going to multiply those two, and that's going to give us negative 6, adds up to 1. So that would be 3 and negative 2. And since the leading coefficient is 3, we're going to divide each of these by 3, and that gives us x plus 1 and 3x minus 2.